Okay, students. So in the last video lecture, we learned this thing that how to find the angle theta if your complex number lies in any of these four quadrants. So I repeat it once more. Okay. See, suppose if x is positive and y is also positive. Okay, mean if x and y both are positive, then angle theta is given by this tangent inverse mod y by x. Okay, but if x is negative, okay, and y is positive, then angle theta it is given like this pi minus tangent inverse mod y by x. Okay, now next if x is negative and y is negative, then we find angle using this formula minus pi plus tangent inverse y by x. Okay, and here if when x is positive but y is negative, then angle is found using this formula minus tangent inverse y by x. Okay, so this rule you always remember. Okay, now next we know that for 30 degree or for 0 degree, uh, pi by 6 mean 30 degree, pi by 4. Okay, and then pi by 3 and then 90. Okay, what are the values of tangent of theta? Okay, mean if theta is 0 degree, then the value of tangent is 0. If theta is pi by 6, then the value of tangent is 1 by under root 3, and for pi by 4 it is 1, for pi by 6 it is under root 3, and for pi by 2 it is not defined, or you can say that it is infinity. Okay, now suppose that tangent of pi by 6, as this value is 1 by under root 3, so if you bring this function to the other side, okay, then what do you get? You get tangent inverse 1 by under root 3. This is equal to pi by 6. So whenever you find this thing tangent inverse 1 by 3, okay, its value is pi by 6. Likewise, when tangent theta sorry, when tangent 45, okay, it is equal to 1, so it means that tangent inverse 1, the value of this is pi by 4. Okay, likewise tangent of pi by 3, it is under root 3, so pi by 3 equal to tangent inverse under root 3. Okay, so these things will be used while solving questions. Okay, so you pay attention to these things, that tangent inverse 1 by under root 3 it is equal to pi by 6. Okay, tangent inverse 1 it is equal to pi by 4, and tangent inverse under root 3 it is equal to pi by 3. Okay, now next we want to discuss that how to write the solution when uh, roots are complex. Okay, so suppose that after solving any problem, okay, you get complex roots like this: x plus iota y and x minus iota y. And you are already aware that any complex number, it can be expressed like this in polar form: r cos theta plus iota sine theta. Now, what is the value of x minus iota y? I mean, here what you do in order to write this complex number in the polar form, you change iota to minus iota. So it is cos theta minus iota sine theta. Okay. Here I am going to use one result which is called the De Morbius theorem. So this theorem states that cos theta plus iota sine theta whole raised to the power n, this is equal to cos n theta plus iota sine n theta. Okay, so this is the very important result which will be used for writing the solution. Okay, so now you see, now suppose that we have these roots x plus iota y and x minus iota y. Now you are aware that for the different roots we write solution like this. c1 x plus iota y whole raised to the power n. Okay, c2 x minus iota y whole raised to the power n. Okay, now now you see that you convert this x plus iota y to the polar form. Okay, so what is the polar representation of this? This is equal to r bracket cos theta plus iota sin theta whole raised to the power n. Okay, and what is the polar representation of this? This is r cos theta minus iota sin theta whole raised to the power n. Okay, so you see that here you can write c1 r raised to the power n cos theta plus iota sin theta whole raised to the power n plus c2 r raised to the power n cos theta minus iota sin theta whole raised to the power n. Okay, so from here we can take r raised to the power n common, and here you have c1. Now apply here de Moivre's theorem. So what it is? It is cos n theta plus iota sin n theta plus c2. Okay, it is cos n theta minus iota sin n theta. So here I applied de Moivre's theorem. Okay, now after applying de Moivre's theorem, what you do? You combine the first term of each bracket. Okay, so here the first term is c1 cos n theta plus here the first term is c2 cos n theta. Okay, after this combine the second term. So what it is? Iota c1 sin n theta minus iota c2 sin n theta. Okay, so what you do? You take cos n theta common from the first bracket, c1 plus c2 into cos n theta, and here take sine and theta common, so it is iota c1 minus iota c2 into sine and theta. Okay, now as c1 is constant, c2 is constant, so sum of two constant is again a constant, so here we can write a cos n theta, and here we can write b sine n. Okay, so this is how we write the solution. Okay, it is r raised to the power n a cos n theta plus b sin n theta, where I have already told you that how to find r is equal to x square plus y square. Okay, now after deciding this thing that way in which quadrant our complex number is, according to that we find the value of theta. Okay, so this will be seen while solving question, but you people remember this thing, that this is the way to write the solution. It is r raised to the power n a cos n theta plus b sin n theta. Okay, so thank you very much students. So more about it will be discussed in the next video lecture.